Okay, use vertical format to prove this trig identity that the left side is the same thing as the right side. So I think the left side looks like it has more stuff going on, a little bit easier to work with. So the right side is the side that I'm going to leave alone. You need to leave one side alone. Don't add or subtract something to both sides. Don't multiply or divide to both sides. That instantly is wrong. And of course, one of the frustrating things about this question type, if you don't remember doing these, is that sometimes you can do stuff, like you can say sine over cosine is tangent, and then you could say cosine over sine is cotangent. But even though that's true, it may not necessarily be helpful here. So it's not, you can't always just say these are the steps that are going to work. But what I notice about 6a is that this side has two terms and the right side only has one term. So that gives me a hint that I need to push these together somehow with an identity, with some algebra, and specifically I think the algebra that's going to work on this one is getting a common denominator and adding these fractions together. So this guy needs a sine in his denominator, so you have to multiply his numerator by sine. His denominator needs a cosine, so you have to multiply the top by cosine too. And then the purpose of getting a common denominator is that we can squeeze this together as one big fraction. Makes the numerator sine squared plus cosine squared. And what is sine squared plus cosine squared?
1.
Okay, and then we get to that point. Now these are not being added or subtracted, so now I can do these in two different pieces. 1 over cosine is secant, 1 over sine is cosecant. So again, there's many ways to do a trig proof. You could do it differently and it could still be fine. As long as you're not doing some like work with fractions where they don't really work that way, or you're plugging in some trig identity that's not really true. As long as you're not doing that, and as long as you're not adding and subtracting to both sides, multiplying and dividing to both sides, then yours should be fine. Also, kind of a common mistake here is to stop right here. And I would hope that if you knew to do this, that you would know how to finish it, but I can't give you full credit when you do this. It looks like you don't know what you're doing. You need your last step to be the same thing on both sides. Also, try to show as much work as you can on these questions. That's the whole point of these questions, is for you to show that it's true. They're not true-false questions. We're telling you that they're true. So if it's your job to show that it's true, make sure that you're not skipping a bunch of steps. Okay, any follow-up to 6a? Any of that I need to go back over again?